For number 24, find the horizontal and vertical asymptotes of the rational function graphed below. As a quick review, I like to use the HOY VUX acronym to summarize horizontal and vertical lines. HOY stands for horizontal lines. They have zero slope, and the equations are in the form of y equals a constant. For vertical lines, V stands for vertical. U means that their slope is undefined. And the equations are written in the form of x equals a constant. So this graph has two vertical asymptotes and one horizontal asymptote. The vertical asymptotes are found at these two vertical lines at this line where, x is equal to -4. And we have this vertical line here where x is equal to +4. Those are our two vertical asymptotes. Our horizontal asymptote is the horizontal line that goes through -2 on the y-axis, so it's in the form of y equals -2. And that corresponds to answer D. Looking at number 25, we want to graph the function. We can graph rational functions by determining if there are any vertical or horizontal asymptotes. The vertical asymptotes will occur where the denominator, for the x values, that would make the denominator equal to 0. So if we set the entire denominator x minus 2 squared equal to 0, that's this, and set each of those factors, set x minus 2 equal to 0 by taking the square root of both sides, we can see that x equals 2 is a solution, or what an x value that would make the denominator equal to 0. So our vertical asymptote is at x equals +2. The horizontal asymptotes depend on whether your function is bottom heavy, top heavy, or balanced. And what I mean by that is that the horizontal asymptotes depend on the degree of the numerator and the degree of the denominator. And the degree is the greatest exponent of the variable. So the horizontal asymptote, in this case, it's bottom heavy because the degree of the numerator is an x to the 0. So we say it's a 0 degree polynomial in the numerator, and the degree in the denominator, when simplified, would be x to the 2nd power. So bottom heavy functions will have a horizontal asymptote that is y equals 0. With those two bits of information, we begin to sketch the graph. We graph a dotted vertical line at +2 in the x that goes through 2 on the x-axis, and a horizontal line that goes through 0 on the y-axis, which is the same thing as the x-axis. Now we can make a table of values. Since our asymptote occurs at 2, vertical asymptote occurs at 2, I like to pick a couple numbers before that asymptote to the left and a couple numbers to the right of that asymptote. By plugging in these x values into your original function for x and simplifying, we see that when you plug in 0, you get 0.75, which is above the asymptote, correspond to this point right here. When x equals 1, the f of x is equal to 3. So when x equals 1, y is equal to 1, 2, 3. Now the graph will approach that x equals 2 will approach towards positive infinity, and it will flatten out as you go to the left. So that's what our left side, if you were to put 2 into this function, you would get an error, and that is what's causing that vertical asymptote. Now if you put 3 into this function, you get 3 out, so we can plot that point, and put 4 in, we get 0.75 out. So we can graph that side of the graph to the right of the vertical asymptote, x equals 2. And this matches choice A. For number 26, we want to determine which of the rational functions given below has the following feature, which has a horizontal asymptote at y equals 3. The horizontal asymptotes depend on the degree of the numerator and the degree of the denominator. So you look at the degree of the numerator over the degree of the denominator. Now these, I call them top heavy, bottom heavy, or balanced. For example A of our choices, for choice A, we see that the degree of the numerator is 2 and the degree of the denominator is 1. So we call this a top-heavy function, and the characteristic of top-heavy functions are that they have no horizontal asymptote. And I'm going to abbreviate that as just HA, no horizontal asymptote. And that happens for top-heavy functions, so that we can eliminate as a choice. For choice B, the degree of the numerator is 1 and the degree of the denominator is 1. And what we're looking at is the highest exponent. So this is a balanced equation, and it does have a horizontal asymptote. The horizontal asymptote depends on the coefficients. So the leading coefficient of the numerator is 3, and the leading coefficient of the denominator is 1. And horizontal lines are in the form of y equals a constant. So that would have a horizontal asymptote at y equals 3. That would be our choice. But let's look at the other two just as a quick review. In part C, the degree of the numerator is 0. It doesn't have an x, so we consider it to be x to the 0 power, and the denominator is 1. We call this bottom heavy. And bottom heavy functions will always have a horizontal asymptote that is y equals 0. It's always going to flatten out to the x-axis. So we can eliminate that as a choice. And choice D, the degree of the numerator is 1, the degree of the denominator is 1. So we're looking at the degree here to determine if it's top heavy, bottom heavy, or balanced. This one is also balanced. So again, to find the horizontal asymptote, we're going to be looking at the coefficients, the leading coefficients. So this would be y equals the leading coefficient in the numerator is 1 and the leading coefficient in the denominator is 1. So y equals 1 would be the horizontal asymptote. So we can eliminate that as our choice. Choice B is the answer.